Hello, and a warm welcome from my side. My name is Johannes Olbort. I'm a project manager at VBMA regarding the development of industrial interoperability with the context of the OPCUA for machinery. And I'm very happy and delighted to be here presenting today at the OPC Day internationally regarding the topic OPCUA for machinery, solving job form management uniformly for the entire shop floor. But first of all, who is the VBMA? The VBMA stands for the Machinery and Equipment Manufacturers Association, representing more than 3,600 member companies from the engineering industry in Europe. We are structured in so-called trade associations, regional subsidiaries, foreign subsidiaries, as well as departments and, for instance, competence centers. The VBMA is also host of several European and global sector committees, and overall we are representing the OEMs, providing the devices for sites like mining sites, factories for discrete manufacturing, or plants for continuous manufacturing. The key point here, before I go into the deep dive, is to highlight the so-called trade associations. For the different machinery and device types, we have for each trade association, for instance, for mining, for metallurgy, for robotics and automation, for machine tools, for glass machines, etc. And all these different trade associations with the different machinery and device types develop their own domain-specific companion specifications, but today we will talk about the harmonization in the VBMA with regards to the base specification of OPCUA for machinery. The VBMA, as already highlighted, is globally active. We are located in the center of Europe here in Frankfurt with our headquarters, but we are having foreign subsidiaries, for instance, in Poland, in Italy, in Austria, also in the United States, in Brazil, in India, in China. And so together with the OPC Foundation, we are very happy that we can be, and we are ongoing, distributing the specification work that is being done in the working groups on international trade fairs and shows, as well as roadshows, for instance, as just previously accomplished in India. Let's get to the point, OPCUA for machinery. I will not give you an overview regarding the communication with OPCUA, so how to get information from A to B. Please refer to the previous and following trade presentations, which will be focusing on that point. Today we are focusing on what to be transported with respect to information models, so-called OPCUA companion specifications. And OPCUA for machinery is our base specification for the machinery and equipment manufacturing industry. It is our harmonized approach regarding a common cross-domain companion specification, which is compatible to already existing companion specification or is the basis for upcoming companion specifications for our entire industry. And it uses the concept of so-called harmonized basic building blocks, which can be used broadly. And each building block stands for a specific use case. You can see on the right here the machine identification use case. And it is very crucial to know that the OPCUA for machinery companion specification can be used as a standalone companion specification, for instance, for only one-time produced special machinery. But it is also possible, and of course, wish that it is referenced by other companion specifications, not just within the VBMA, but also in the broader OPC Foundation community. So overall, we are thinking that we can be, and we are providing a very important piece and aspect with OPCUA for machinery for cross-domain interoperability in the context of information models. So let's take a brief overview regarding the building blocks of OPCUA for machinery. We started with machine and component identification, which is derived from devices, enabling also in this context the use cases for finding all machines in the server and finding all components of a machine. This is done by using a so-called machines folder object, which is directly integrated into the server object, in which all the different machines that the server is representing are to be placed. Of course, if the server is only representing one machine, then it can be found as well in the machines folder. The same concept applies for components of a machine. They are structured within the machines folder. We have the speciality here that the second building block, the machinery state, it enables the monitoring of information regarding a specific machinery item with the context to state and operation mode. Machinery item state, the state machine has the states not available, not executing, out of service and executing. And for instance, executing is then inherited by the extrusion companion specifications from plastics and rubber machinery and extended with the substate machine for the execution state. The same with the machinery operation mode, which has the states non-setup, maintenance, and processing. The maintenance state was in the context of machine tools extended with a substate machine for this particular domain. Which is very important with respect to machinery state is that in Annex C of the machinery specification, there's an example given on how the state and operation mode, together with a high level system state, can be used as a base for KPI calculations like availability or efficiency according to ISO 22400, which is called Automation Systems and Integration KPIs for Manufacturing Operations Management. The fourth building blocks are the counters. The counters enable use cases related to preventive maintenance with operating and lifetime counters. These are fulfilling the requirements to know the total time a machinery item is turned on and the total time an activity is done. And these can be accessed as well as the remaining estimated lifetime of a machinery item or other aspects. So, for instance, the license validity or the parts produced. The next building block is separated in a known part 101. This is result transfer. Result transfer ensures the uniform retrieval of complex measurement results, e.g. from machine vision or geometric measuring systems in a uniform way. This is the main purpose, and it's done by providing metadata together with the individual results. The next part, part 2 of machinery specification, process values, is there to provide mechanisms related to the representation of process values for domain-specific companion specifications, enabling use cases for the user like to access the process values of a machine and its various metadata like ranges, precisions, and unit, as well as to set the set points for a process value of a machine by extending the analog signal type from PADIM here. The upcoming energy management building block will be based upon the current and ongoing work in the joint working group energy consumption management, which started with the title Power Consumption Management. It is a joint working group from ODVA, OPC Foundation, PI, and VBMA, and we are chairing this group. And this joint working group is picking up the task to develop and harmonize a new interface standard for the acquisition of energy consumption data in industrial manufacturing. But let's get to the point why we're all here today. We want to know everything regarding the context of job management. And let's talk about the actual deep dive right now. In case you're just joining, please also note that the previous presentation of Dennis Brandl from ISO 95 regarding job control is a highlight, and you should be looking it up in the recordings of OPCD International Day 4. So what were our goals? We started in 2021, and as always, you start with the use cases and taking them into considerations. What do you want to do? In our context, we wanted to be able to monitor the jobs. the actual start time, the actual end time, and bring all these from the higher level system like an MES to the machinery item. And of course, we also wanted to control the jobs. We wanted to abort them, we wanted to pause them, etc. Then we needed to get status information and end results together with quality context, like job-related process values. Of course, also the bill of materials. So what were the actual parts used for the job? Then in the end, clean everything from the machinery item because it is not a database. And we took into consideration the already started and defining work regarding job management. So in VBMA, for example, it was flat gas processing, injection molding machines, machine tools, etc., like woodworking. But globally, of course, ISO 95 for job control, based on the IEC 62264, was a crucial part to take into consideration to have a deeper look at. That's why we have founded the collaboration here with this group and overall to enable a common model for job management using the modeling principles for extensibility, modularity, and of course the reuse of existing concepts. And it was a quite challenging but overall a very fruitful ongoing work, which highlights are the release candidates from ISO 95 from May and from machinery in June. Let's start with the basic idea. In our production environment, we want to highlight two stakeholders with the lifelines. On the left-hand side, we can see the upper-laying system like an MES, and on the right-hand side, a machinery item. We start with sending the job order from the left-hand side to the right-hand side. A job order is a request for a unit of work to be executed. And associated with the job order, there are so-called parameters, which are additional information and that are represented in name value pairs and defined so-called job order parameters. Then there is the scheduling and the starting of the job with a status and change notifications. A job order then, once it is executed, is sending a response as a report of the work done for a job order back to the upper laying system. This job result contains additional information associated with the job, also represented in name value pairs. And this is the basic idea. We want to take a deeper look at it right now. The approach we took. First of all, as one element, we defined the mechanisms, so the information model and how to exchange the data. This is done in the OPCUA for ISO 95 Part 4 companion specification regarding job control. After that, we defined the information, as I already said, the job order parameters and the job response parameters, which are then transported using the defined mechanism. In our context, we can see that the job order, which was planned and then executed, is sent from the upper laying system to the machinery item. During the runtime and the execution of the job order, we want to get the status information and in the end, the job result when the overall job was finished. But let's take a deeper look at the status. The status of the machinery item is based on the job state machine defined in ISO 95. The previous presentation by Dennis Brundle explained it in depth. That's why I will only give a brief overview. A job order is added to the system, and this is done from the start point via the methods for store and start, when the states will either be then not allowed to start or allowed to start. When a job order is in the state allowed to start, the system may automatically start the job order depending on available resources and priorities in case several job orders are in the same state. If the allowed to start state provides substate, they may indicate if a job order can be started, e.g. waiting indicates that it cannot be started. When the job order then starts to be executed, it switches its state to running. And clients might or may interrupt the running job order by calling the pause method. The system may also automatically interrupt the job order. In both cases, the state switches to interrupted, and substates may indicate if the interruption was triggered from external or, for example, suspended or automatic, like held. And clients may resume the execution of an interrupted job by calling the resume method, or the system may automatically continue. In both cases, the state switches back to running. When the job order was executed, it automatically switches its state to ended. And substates of ended may expose whether some post-processing needs to be done before receiving the final results of the execution. So some job orders may not be defined to finish its execution automatically. In addition, some job orders may get stopped before the planned amount of the job order is produced. In both cases, the stop method is called to end the execution of the job order. And this can either be done while in running or interrupted. In both cases, it switches to ended. And with a clear method, they can both be removed from the machinery item. Now, after we took a look at the job state machine, let's dig deeper into the information model. And to do so, please be aware that we request so-called machinery building blocks folder within an OPCUA server supporting OPCUA for machinery. And within this machinery building block, we will be seeing the instant representation of the job management type. And within this job management type, very important to see is that in job order control object, we are not only representing the job order receiver object type, but also the job response provider object type within the job order results. And critically important is here within the job order receiver object type, next to the methods to receive and control job orders, we have the job order list as an array of job orders managed by object. And critically important here is the order of execution of the jobs in the job order list. That is that the array shall start with all executed job orders in the order the execution started, followed by all job orders currently executed or interrupted in the order of the execution started, followed by the job orders that can start to be executed, followed by the job orders that currently cannot start to be executed. And the objects that can be executed shall be ordered based on the start time and priority. And what do we need all in a job order now as an input here within a job order list element? This will be shown in depth in this next slide. Going to the job order result. The job response is the report on the execution of the job order. And next to the job state, it contains the job response data. And as well as with the job order parameters, the job response data, we will take a deeper look in the next slide. So let's get to the next slide here then. Now let's take a look how it is integrated into an OPCUA server supporting this OPCUA for machinery part 3. We can see here in the currently visible figure the so-called machinery building blocks folder, which contains here the job management type with the two objects, job order control, job order results. You can see that they both derive from types from ISA 95, one from ISA 95 job order receiver object type, and on the other hand on ISA 95 job response provider object type. We've seen them in the previous figure in detail. They're both integrated as add-in with the mechanism here defined. And let's take a deeper look what is the content of a job order in the list of the job order control object here. We have a defined set of parameters we want to supply with the job in the job order list. For instance, the runs planned, which indicates the number of runs that should be performed by the targeted machinery item when this job order is executed, and a run can consist of several steps. There is the association with the work plan here. Then there's the planned time per run, which is the time period that is needed for the execution of one run of this job order, etc., etc. They are all defined, and you can read them in detail within Table 1 of the specification. And then on the other hand, we have the job order results, which is a list with the job responses, and they also have a defined set of parameters. The green highlighted parameters and data are common for both objects. Meanwhile, for the job response data, for example, there is some specifics like runs completed, which is a counter that increases after each completed run of this job order. There's the run started, which is also a counter, but it indicates how many of the runs planned have been started already. There is the actual produced quantity. There are several other already defined mechanisms here. Then we have in OPCUA for machinery part 3 job management also a lot of additional data types. For instance, you can see here the job execution result, which is the high-level result of the execution of the job order with, for example, unknown, successful, or unsuccessful. There is also the as-built BOM, which is the bill of material of the produced output of the job order. You can see it in the predefined parameters for job response data, and it is now an additional data type with the BOM information data type. So in overall, we have all these optional parameters in OPCUA for machinery, but they can be then made mandatory by the defined domain specification, for instance, like OPCUA for machine tools, which is deriving from this specification part then. So overall, we have the high flexibility and modularity within OPCUA to get a sophisticated overall solution for job management. Let's take a step back. It was quite a deep dive we just had together in ISO 95 job control and OPCUA for machinery part 3 job management. But not all our member companies are equipped with technical experts who are so deep into the technology of OPCUA and the associated companion specifications. That's also why I would like to take the opportunity here to get the focus onto the so-called guidelines we published within the OPCUA. But both of the now presented guidelines were developed by participation with representatives from the OPC Foundation. And the first one is a new version of a guideline first published in 2017 with the title Industry 4.0 Communication with OPCUA, which was mainly tailored to the SMEs from our membership. And it was supposed to lower the barriers and the hurdles with regards to develop a mesh communication network within their companies using OPCUA. That's why also one of the main contents was the so-called migration path on how to get OPCUA introduced into your production environment. And we published for the Hannover Fair, the German version, and we'll be publishing for the EMO in Hannover this year, the English version. On the other hand, we had a new work being published also at Hannover Fair with the title Industry 4.0 Interoperability through OPCUA with companion specification, which was not supposed to take a deeper look at the technology, but to represent the usability of OPCUA with companion specifications, both applied for discrete but also continuous manufacturing, where we highlighted within 2 different scenarios how the technology can benefit the OEMs, the system integrators, but also the operators with regards to different stakeholders. So for example, why is it beneficial for the salesperson at the machine builder? Why should purchasing within an operator be looking at OPCUA when defining the requirements for new equipment? Or also, why should system integrators take a deeper look at how they can broaden their variety of different equipment they could integrate for customers, for instance? And we will be seeing the English version of this document as well at the SPS Nuremberg Fair this year. And I would like to briefly point that out here. Just as well, we would like to point out to save the dates for mostly our members, but also for members of our partners like OPC Foundation. We are hosting a so-called shop floor interoperability user summit this year in Frankfurt, where we will be seeing from big end user companies like BMW, Deutsche Bahn, and others presentations regarding their experiences, their needs with regard to OPC and companion specs to get into their production as well, mesh communication network with also the semantic data that is defined in companion specifications. And overall, also with participation of the OPC Foundation, we are happy to host a so-called Interoperability Summit where we will be highlighting also OPCUA with companion specs as our main effort in the last years. But on the other hand, we are seeing various other technologies arising and already existing that could be complementary to OPCUA with companion specs. And we need here to take a broader look on why overall the ecosystem is challenging and changing, but needs to be consistent with regards to our members, but also our customer industries. So overall, I would like to briefly summarize the presentation. OPCUA is set. It is the base technology we are seeing for interoperability with regards to communication for the future, which is meeting all the requirements that we are having. So basically what we drive here is always see with OPCUA with regards to communication that it is always to be considered in combination with the information layer on top of the communication layer. That's why OPCUA companion specifications for our domains, for the cross domain with OPCUA for machinery, but also for the different domains like machine tools with their respective domain specific companion specification. Overall, the ISO 95 group together with OPCUA for machinery group developed here a harmonized and extendable and modular solution solving job management for the entire shop floor. And OPCUA for machinery solves various other use cases as well using the concept of so-called building blocks. And we are happy that in combination, we are seeing here the harmonized and suitable solution upcoming for all the challenges we are facing with regards to job management and for various other monitoring and control use cases within the shop floor regarding our machinery items. So thank you very much for listening to my presentation. I hope you enjoyed it a lot. Just as I will also like to highlight out the previous presentation from Dennis Brandl from ISO 95. Together with OPCUA for machinery, we are seeing an overall solution for job management suitable for meeting the requirements of our future. And both specifications, ISO 95 job control was released in May, and OPCUA for machinery was just released now, are still in the review phase. And feel free and please take a deeper look in the specification work so that within the review phase with your comments, we are able to get the two specifications to a higher level and meeting a level with a higher maturity here. Thank you very much for your attention.